Hi everyone, today we're going to look at how we can solve a proportion. Before we get into solving a proportion, I'd like to look at some equivalent fractions with you and remember all the things that we know about equivalent fractions. We know that the numerators within equivalent fractions are connected to each other in the same way that the denominators are, through multiplication or division. So in this case, we can look at 2 and know that if we multiplied that by 2, we'd get 4. In the denominators, if we multiplied the 3 by the same 2, we would get 6. This proves to us that these two fractions are equivalent. There's another connection within equivalent fractions that we should remember as well, and that is that if we divide the numerator by the denominator, we should get the same decimal value on both sides. So 2 divided by 3 will give us 0.6 repeated, and on the other side, 4 divided by 6 will also give us 0.6 repeated. This again tells us that these fractions are equivalent to one another. There's a third connection between equivalent fractions that is not always as commonly known. If we look across the diagonals of the equivalent fractions, the 2 and the 6, if we were to multiply those together, we'd get 12. If we do the same to the other diagonal, the 3 and the 4, we'll also get 12. This is a consistent characteristic of equivalent fractions. We call this idea cross multiplication. So we multiply across the diagonals in each case, and they will be equal to each other if the fractions are equivalent. We'll use this idea as we solve proportions. So a proportion is like a set of equivalent fractions, but one of the items, a numerator or a denominator, are missing. We'll have a variable in its place. But we'll use the idea of cross multiplication to help us find the value of that missing item. So if we look diagonally at the two numbers we know, the 9 and the 4, 9 times 4 will give us 36. In the other diagonal, 7 times x will give us 7x. We can find the value of x easily at this point by dividing both sides by 7. This will leave us with x is equal to something like 5.14285714, but we can round this off to x is approximately equal to 5.14. Our proportion might also involve decimals, but the same property of cross multiplication will work. We can multiply this 3.7 times the m to get 3.7m. And across the other diagonal, we'll multiply 1.4 by 6.1, and we'll get 8.54. If we want to solve this to get m by itself, we're going to need to divide both sides by 3.7. When we divide 3.7m by 3.7, we just get 1m. On the other side, when we do 8.54 divided by 3.7, we'll get something like 2.30810811. We'll round this off to two decimal places. So we'll say m is approximately equal to 2.31. Occasionally, we might see a proportion that doesn't quite look like a fraction equals to a fraction. In this case, we have a fraction equal to a whole number. But we can fix this by putting a 1 underneath the 12, because of course 12 is the same as 12 wholes. Now we can cross multiply. So we will look at 1 times w is equal to 5 times 12. 5 times 12, of course, will give us 60, and 1 times w is the same thing as just w. So now we know that w is equal to 60. So using cross multiplication can be very helpful when we're looking to solve some proportions.